the x-axis, take this function, reflect it over the x-axis, then translate it 2 units right, a vertical translation of 1 unit down. So you're told that this is the parent function, write the new function at these shifts. So it's cubic, right?
Yep.
So we have y is equal to, shifting for all functions works the same. First of all, if it's shifted left and right, it's in with x in parentheses, right? So I'm going to do that first. We're going to have an x, and then it says 2 units right. Don't we go opposite for this? Minus 2. It's still got to be a cubed function. Just shift it now. And then vertical 1 unit down. That's added to your function on the outside of the function. Now, a lot of you got that far and you forgot the flexion over the x-axis. Isn't that a negative in front of the function? Okay. Do you have questions on that? Please ask. That's why we're doing this. I'm not putting, we do the quizzes so that you know what you don't know, I'm not putting it on your grade because, like I said, it was bad. So right now, you're figuring this out. Are we all good? Okay, next problem. What are the real zeros? First of all, I don't really, there was one person that got this right. What are the real zeros? First of all, you could graph it, see where it crosses the x-axis. If it crosses the x-axis, that's called a real zero. It's not imaginary. It's crossing the real number line. That's one way of doing it, but I want an exact answer. So, I don't really want the decimal answer. I didn't say a decimal answer is acceptable in the instructions, did I? So I would want the pretty answer. That's what I called it on some of yours. So, let's get the pretty answer, and then let's use our calculator to check it. So the pretty answer is just using algebra. Guys, think about it. If it's crossing the x-axis, wouldn't that be when y value is 0? If it looks something like this, wouldn't that be when y is 0? Let's plug that in. 0 is equal to negative 2 times x plus 3 cubed plus 8. There was one like this, exactly like this on the stage review. Okay, solving for x algebraically, right? That's all we're doing here. What do we do first? Subtract 8 from both sides. So we have negative 8 is equal to negative 2 times x plus 3 cubed. Then divide both sides by negative 2. So we have 4 is equal to x plus 3 cubed. Cube root both sides. Cube root both sides of the equation. If that comes out as a decimal, then you will see if you can pull out groups of 3. If you can't, you leave it. So look, 2 and 2. Are we going to be able to pull all 3 of them? So you'd leave it. So we have the cube root of 4 is equal to x plus 3. Look, root cancels out with power. We have one last step. What do we do? Minus 3 from both sides. So that's a plus sign in between, right? Let's positive this, minus 3. So our answer is x is equal to negative 3 plus the cube root of 4. Yeah, you could write the cube root of 4 minus 3. Let's all practice this. You could check your answer. You're like, okay, that's a pretty answer. Let's graph it in our calculator. You have negative 2 times x plus 3 cubed plus 8. Graph. And you see where it crosses the x-axis, right? Everybody? Second, trace, 0. Left bound. You got to scroll to the left. You should all be practicing this because I know how to do this. Scroll right. Hit enter, hit enter. So the decimal was negative 1.412599. Let's see if our answer is equal to that. You type into your calculator just in like the normal window, negative 3 plus the cube root. So you'll have to go negative 3, go to math, plus, and go to math, down to cube root of 4, and you get the same decimal. So we can check our answers. Questions? Okay, you're sure? Next one. Okay, this one should not be missed, guys. This one should not be missed. It was a little bit harder. Well, So here's the thing. This one was kind of tricky in this sense. It says, what is the quartic function that will have only these two real zeros? But what concerns me is that a lot of you weren't able to, because if it's a quadratic, it's easy, right? Wouldn't it just be, you get this equal to 0, multiply it together, right, guys? So the only tricky part is it didn't say specifically anything. It just says write a quartic function with only two real roots, 7 and 13. So if you think about it, we can only cross the x-axis at, 7 and 13, wherever that is. It's only crossing at 7 and 13. It can't cross anywhere else or isn't that a real 0. Is everybody understanding what I'm saying? So doesn't that mean I would have to have, since it's quartic, we know it's degree 4, doesn't that mean we have to have two imaginary solutions? Yeah, right? So let's come up with a quartic function that has these two real zeros and has two imaginary zeros. So we know for sure x is equal to 7. We know x is equal to 13. Let's come up with two imaginary roots. Wouldn't that be a quartic function with those are the only two roots? Do you get what I'm saying? So I'm going to go with something easy. X is equal to I, and x is equal to, I'm going to use the conjugate, negative I, because wouldn't that have to be the root if this was the root? Now, you guys, you've got to be able to go backwards. So we're going to write it out in standard form. So we need it set equal to 0, so we're going backwards. If this was a root, then x minus 7 was a factor. If this was a root, x minus 13 was a factor. So we have x minus I is equal to 0. We have x plus I is equal to 0. So then we'll multiply those together, right? X minus 7 times x minus 13 times x minus I times x plus I. Then we multiply these two together. A lot of you weren't able to multiply those two together correctly. So that's x squared minus 13x minus 7x plus, what do we get here? 7 times 13. 91. Yeah, 91. So let's combine like terms. X squared minus 20x's plus 91. That would be a quadratic function, right? So if this would have been quadratic, that would have been our answer, right, everyone? Right? Okay. And then we'll multiply in this. Let's multiply it together real quick. That's x squared. Our middle terms will cancel out since they're conjugates. Minus I squared. I times I is negative I squared. So that's x squared minus what? What is I squared, guys? Negative 1. So it's going to be multiplied by x squared plus 1. We would multiply it out. X to the 4th minus 20x cubed plus 9x squared plus x squared minus 20x's plus 9. Then we combine like terms. X to the 4th minus 20x cubed plus 10x squared minus 20x's plus 9. 91. 91 times 1. Thank you. Now, I hope that doesn't seem like it's too hard, because really, guys, secondary 3, just all the problems are, that long, for the most part. Like, you guys know, we've been doing it all year. So, I know you can do it. Just do you want to do it is the question, Does everybody understand that? So what if, yes? X squared. Oh, yeah, because I did 9 times, huh? I'm seeing that as a 9. Yeah, you're right. I was seeing this as 9, guys, right? Yeah. 91. So this right here would have been, that times that would have been 91 x squared, not 9 x squared. Yeah. Thank you. Thank you for that fix. So I saw one last year on the final exam that said, write a polynomial. Let me just let you guys practice this. Ready? It said, write a polynomial with these exact roots. in standard form. With these zeros, x equals 1, x equals 2, x equals -3, x is equal to 0. Ready, go. All right. What is the simplified form of this? What are the excluded values? So guys, isn't this a rational function? Rational? Guys, rational means fractions. You see how it's a function? It has an x, right? It's a rational, meaning fractions. It said, what is the simplified form? I know we know how to simplify rationals. We've talked about it so many times. Don't we factor it? Divide out common factors. But before we divide out common factors, before we divide out, hey, are you listening? Because you guys really did that on the quiz. If we are dividing out common factors, we have to exclude values first. Okay, let's factor it, guys. This is a very easy problem. What is it on top factor? X minus 1. There's nothing to factor out of that, correct? Okay, awesome. On bottom, 3x minus 3. Is there anything in common? A 3. We're factoring out a 3. Then we're going to put what's left inside after we pull the 3 out of each term. So left on the front term is x, and then what? Minus 1, right? Yes, we're almost to that point. Now, before you divide out anything, you have to exclude the values, because this is the function right here. Yeah, we simplify it for our final answer, but this is the function. So you've got to exclude values before anything else. Guys, in a fraction, the bottom cannot equal 0. Your calculator will tell you it's undefined. You can't divide by 0. So you would look at it and say, when does this bottom thing equal 0? So look, 3. Does 3 have a variable? Will 3 ever be 0? No. Okay, a lot of you said 3 was a restricted value. Not true. But look right here. Isn't there a possibility for a 0? So we would say, when does x minus 1 equal 0? Let's figure that out. Add 1, right? Yeah. So x cannot equal 1, because if we plug in a 1, we're going to get a 0. So you would say, okay, x cannot equal 1. I'm going to remember that. That's not my final answer. Now we can simplify. You only divide out exact factors, and most of you did you did some majorly bad things here. What's x over 1 over x over 1? 1 over 1. Does 3 float to the top of a fraction? No. We have a 1 on top. On bottom we have a 3 times a 1, which is a... That's our answer, as long as x does not equal 1. Guys, that was an easy one.
I remember how to do it.
Remember it a week from now, people, okay? Like right now, I know that right now, but you guys, in a week from now, you better know this stuff still. Yikes, okay? How about you guys give her a go? Give her a go. So on top, we factor it. What's in common? 2. So then left is, make sure you're paying attention. You gotta know this in a week from now. What's on bottom? Okay, careful, think about this. It's quadratic, right?
Yes.
We know how to factor quadratics. A times C adds up to B. What's A times C? 1 times negative 16. B is 0, right? Guys? Right? 4 and 4. Negative 4 and 4. It's quick factoring, that's a 1. This factors to be x minus 4 times x plus 4. Before you divide anything out, we need to exclude the values. The only problem is if the bottom equals 0. Top can equal 0, doesn't matter. The bottom cannot equal, instead of equal to 0, solve. 4 and x cannot equal. So that's what we'd say first. X cannot equal 4 or negative 4. Now let's simplify it. Exact factors. Becomes a 1, becomes a 1. 2 times 1 on top is 2. On bottom, 1 times that's just that, right? That one really wasn't too bad either. I mean, it wasn't. Definitely not. Questions? Go. Okay, now before you do this one, I need to say one thing, okay? Because some of you got almost there, but you messed it up. Okay? What is the simplified form of this? What are the excluded values? So I think what threw people off is this is not in standard form. Can't we rewrite it in standard form if we want? Yes. Look on top. Okay, so what would come first? A negative x squared and then plus 25, right? On bottom we have x squared minus x minus 20. Now I want to say one thing. Are we going to be able to quick factor this as it is? No. So we've got to, let's make it easy on ourselves. Can't we factor out a 1 always? So can we factor out a negative 1 right here, right now? So on top, that's the first thing I'm going to do is say I'm choosing to factor out a negative 1. So that would leave me with positive x squared minus 25. And on bottom, we still have this. Now, we're not done, though. You have to say, am I factored completely? Can't this factor further?
Yeah.
Yes, right? Yeah? Okay, you finish. Go, go, go. You factored this key. Tell me, did you get, so we have a negative 1 in front, right? Then we have x minus 5, where I just highlighted, times x plus 5, right? Right? We all get that on top. On bottom, we did 1 multiplies to be negative 20, add up to be negative 1. 4 times 5, negative 5, right? Quick factoring. This factor to be x plus 4x minus 5. Before you divide anything out, exclude your values. So we know x cannot equal what? Negative 4, right? And 5? Is everybody good with that? Now we can divide out exact factors. That becomes a 1 and a 1. There's a negative 1 on top left. If you thought you get it wrong, you have an x plus 5 on top in parentheses, and on bottom we have x plus 4, right? This would have been our final answer. Plug in a negative 5. We're setting each of those equal to 0, right? If you plug in negative 5, that's negative 10, which is great. Does that make sense? Okay. Good question. It's good to get this worked out, before we take the exam in a week. Okay. Holy schmoly! This is the easiest problem I've ever seen in my life. Let's do it together, really quick. It says the length of a rectangle can be represented by the expression x plus 6. The area of a rectangle is this. What's the expression for width? There's like 4 different ways you can do this. In this class, we've learned like 12 different ways to do this. So we have a rectangle, right? Guys, pay attention so this makes sense. I can promise you, pinky promise, every single one of my secondary 2 kids could do this problem. Every time. The length of the rectangle is, this is a secondary 2 problem. The length is sorry, I'm reading it wrong. X plus 6, right? Everybody? And then our area is the filling in of the inside. That's 2x squared plus 8x minus 24. Mason, did you get this one right? Then listen to me. Okay. So, isn't area, guys, length times width? Right? So let's put in what we know. Isn't our area 2x squared plus 8x minus 24? Isn't that our area? That's equal to our length, which is x plus 6, times our width. We're solving for width. What do? We'll get width alone. Divide. Isn't this multiplied? Divide by x plus 6. Divide by x plus 6. Don't we just simplify that now? Right? Okay. So you factor the top. Divide out common factors. That's one way of doing it. Another way of doing it is synthetic division. Can we divide polynomials by synthetic division? So that's personally how I chose because it's quicker for me. But we could just factor the top, factor the bottom, divide out common factors. Width is equal to whatever left over. Does everybody understand what you're doing on that one? Hotter than these. Or am I just having practice from all the bad scores? Okay, that could be. All right. Do I need to keep going, or do you think you could do it? Okay. I just want to get in a few more. Holy cow! I don't know, because I didn't even go to this page. Let's pray that some of you got it right. Here we go. Pay attention. What is the product? Guys, isn't multiplying fractions? It doesn't matter if you have a common denominator. Right? Can we multiply anything? Yes. So what we're going to do is just multiply straight across, factor, divide out common factors. So we're going to put it together here. There's many different ways you can do this. So we're doing this times this, so let's multiply straight across. On top we have, and on bottom we have 2 2x to the 5th. Now that is our answer, but we got to put the most simplified answer. Don't we know how to simplify fractions, rationals? Right? So 28 divided by 2 is 1 over 14. 14 over excluded. Are some of you kicking yourself like, what the heck did I do wrong?
Yeah.
Okay. Next one. Okay, if we're factoring something like, multiplying something like this, won't we multiply straight across and then divide out common factors to simplify it? Let's look right here, right now. Is there anything in common that's going to divide out? No. Isn't this all in factored form? No. So we'll just multiply it together. So you multiply the top straight across. So we'll have x plus 1 times x plus 2. So now we will put those together. That's x squared, because nothing divided out. Does everybody understand what I'm doing here? Plus 2x plus 1x plus 2. So when we have x squared plus 3x, guys, we're to do this slowly, plus 2 on top, and on bottom, we have this times this. Don't we need to put parentheses if there's two terms?
Yes.
So that's x squared minus x, and we do nothing divided out, right? So we're done. Because we would have divided first before multiplying. Questions? Okay. Whew. Yikes. It says, what is the quotient? You will see one like this. You will see one like this in a week and a half, people. It says, what is the quotient? Doesn't quotient just mean division? So we have this picture. We have x minus 2x minus 2 divided by 2x plus 6 divided by this. Dividing fractions, as easy as pie. You flip the second fraction and you multiply. So isn't this, pay attention, isn't this over what? 1, right? So we'll flip the second fraction and multiply. So we have 2x minus 2 over 2x plus 6. We're flipping that second fraction. So now there's a 1 on top. And on bottom there's a 3x squared minus 3x. And we're multiplying. Now when we multiply, we're going to listen because a lot of you do this wrong. When we multiply, don't we know? We multiply straight across, but then we need to divide our exact factors. So wouldn't it be easier to factor it when it's pieced apart like this? So let's factor this piece. This 2x minus 2. What's in common? So then left is x minus 1. And on bottom we have a, and left is, and then we are timesing by, we still have a 1. What's in common? And then left is, just be careful. Now we would be multiplying straight across. So let's, and then we will divide out exact factors. So let's just divide out exact factors. 2 over 2 is 1 over 1. X minus 1 over x minus 1 is 1 over 1. Anything else? 1 times 1 times 1 on top is? On bottom. 1 times that. Isn't that just 3x times x plus 3? That would be an acceptable answer. Or you can multiply that in. Either one would be okay. Okay. So go for it. Go for it. Get it right. Divide, it says, what's the simplified form? That doesn't always mean division, but in this problem, isn't it a division problem? Dividing fractions is easy to type with second multiply. We have 5 over x minus 1. We flip the second, that puts our x squared minus 1 on top, divided by 10x, right? Now I'm not going to multiply this together yet, because that's going to make it bigger stuff for me to factor. I'm going to factor everything, divide out common factors, then multiply, right? So let's factor each piece. 5 over x minus 1, it's done, right? Let's factor this piece. Doesn't that factor? Yeah. X minus 1 times x plus 1, right? 8 times c adds up to b. Guys, we should be better at factoring than we are. Divided by what? 10x. Now, I'm going to divide out common things before I multiply, right? Because then it's just smaller things. 5 becomes a 1. This becomes a 2. X, nope. X minus 1 on top. X minus 1 on bottom. So left on top was a 1 times the x minus 1, right? X plus 1, I mean.
Yeah.
On bottom, what was left was a 1, a 2, and an x. 1 times 2 times x. 2x. And now look, we didn't have to, you know what I mean, guys? Everybody good? Okay. Make sense? We still have 10 minutes. Let's do these two. Holy cow, these are freaking easy. They have a common denominator, people. Did we even have to fix these problems? No. Adding fractions or subtracting fractions, you have to have a common denominator. If you do, you combine the top, it's over the bottom, then simplify. Go. Do I need to do one with you? Or are we good?
We're good.
Okay, go. Get it right. Get it right. Get it right. The easy ones. They'll give you harder ones than this. This is to warm you up. We have common denominators, so you add across. That's 10 over 4b. That is our answer. We just always simplify our answers. This becomes a 5, this becomes a 2. Don't they multiply by 2? 5 over 2b. Is that right? Okay, moving on. Common denominator, so we're golden. It's addition, so we don't have to worry about anything. Just add it straight across. 2 h's plus 7 h's is how many h's? 9 h's over y minus 2. And done. Can we change this to an h? Can I divide out those h's? Can I divide out the h's? Absolutely not. H is connected to minus 2, right? Only if it's multiplication, right? I was just changing it to get you thinking. It was y. I changed it to get you thinking. Does that make sense? Okay. Okay. Don't make this problem harder than it is. This minus this. So we have a common denominator. Go. Subtraction, you do have to be careful. Get it right. Go, go, go. Yeah, always. Our answers are always in simplified form. So first of all, subtraction. If you're going to be seeing an addition or subtraction problem, there's a good chance they'll do subtraction to see if you know how to distribute a negative, which you should be able to. So we're subtracting all this stuff, right, guys? So we've got to distribute the negative through. So that's, I hate the cross line change the sign thing, but whatever floats your boat. Cross line change the sign, right? Whatever you want to call it. Really, we're just distributing -1 and a positive 6x, right? -1 times -1 is positive 1. Okay, so now it's addition. We've distributed our negative through, so now it's addition. So now we'll combine the top. So -4x plus 6x's is 2x's, right? So we have 2x plus 1 over 2x squared plus 13x plus 6. Now you can say to yourself, that is my answer, but is it possible to simplify? Well, it's a rational fraction, right? There's a good chance that this could be a problem you'd see because it's testing, do you know how to add and subtract fractions, and now do you know how to simplify them? You know what I mean? We're testing to see if you've learned all that you should have learned this year in 30 problems. So you get that, right? That it's going to have multiple steps. Does everybody understand? So we factor the bottom. The top did not factor. We had x plus 1. The bottom does factor. You'd have to long factor. Do we need to go through that real quick? We're all good? You can all factor? So your factors on bottom were x plus 6 times 2x plus 1. Now you can divide out exact factors. In the instructions, it didn't say anything about restricting the domain. That becomes a 1. Don't let that just disappear. That becomes a 1. Left on top is 1. Left on bottom is x plus 6 times 1, which is x plus 6. Questions? Okay. Last one, we have 5 minutes left of class. Looking at this problem, guys, it says, simplify this. Isn't it addition or subtraction of fractions? Do we need common denominators? Fix it. Go and simplify. Okay, listen up. I'm looking it through this problem. Are you ready?
Yes.
So we have to have a common denominator. So I'm going to multiply by x plus 5 over x plus 5. I'm going to multiply by x plus 1 over x plus 1. Now look at the denominators. Are they the same? Yeah. So we're going to distribute. So we have 7x plus 35, right? They have it